Next, I will talk about the sensitivity of the clay, and I will show how you can perform the test, and I can show some specimen result from the vane shear test. The term sensitivity is defined as the ratio of undisturbed to the demolded strength of clay. Now, sensitivity clay are those having the value of sensitivity between 4 and 8. Higher the value of sensitivity means the more sensitivity in the clay. Now, to perform the vane shear test, you require that certain apparatus, that is laboratory vane shear test apparatus, that is self-contained, having the essentially the following: one is the frame and the stand, then vane mounting assembly, then handle for rising and the lowering the vane assembly by means of the square thread lead screw. So, I can also show you later that equipment. Then this is the vane with the 4 blade, 12 millimeter width and 25 millimeter long, handle for rotating the vane head, graduated scale mark in degree, one of the fixed vane head, another rotating with the vane, then rotation pointer, vertical shaft attached to the knob, fitted with the pointer carrier on the friction slips, set of spring, usually 4 of different stiffness to allow for a range of soil strength. Then calibration chart for the spring, a means of supporting and clamping a 38 millimeter diameter sample tube close to the edge, drying oven and cans for obtaining the water content, and spatula, trimming knives, steel rule and stopwatch or timer. So, now I will show you that is the equipment. This is the vane shear test apparatus, and soil is in this mold and vane is inserted. This vane is inserted here, and then torque is applied. So, you can apply the torque and it will rotate certain angle. So, you can make that some initial angle, then you can rotate further, and then you go for the final angle, theta final. So, you can determine that what should be the theta initial and what should be the theta final, and you know that what should be the thickness of the spring, and then you can determine what will be the torque applied onto this sample. So, this is the vane shear test equipment. This is very simple test, and the equipment also is very small. Now, what is the procedure? First of all, the preparation of the test specimen. Clamp the sample tube securely, keeping it axis vertical and with the end to be rested uppermost. Then remove any end cap, wax, seal or packing material and trim the sample above tube, so that upper end is flat and perpendicular to the tube axis. Now, bend shear test: clamp the tube in position and select the spring, prepare apparatus and adjust the scale, measure initial angle of twist, insert the bend and measure the final angle of twist, and then measure the shear strength. Measure shear strength, remold the sample, repeat the step 3 to 5 times to obtain the remolded shear strength. Remove bend and measure the water content as well as density. Repeat the above step on a fresh sample at least one and calculate and report the result. I can show you that what should be the sample calculation for the bend shear test. Let us some specimen calculation. So, this is the specimen calculation for bend shear test. So, I am just showing you one specimen calculation for bend shear test. You know, height of the bend is equal to h is equal to 2.4 centimeter. Then diameter of bend, that is D, is equal to 1.2 centimeter. Let us say water content is equal to 75.15% and dye density, let us say 0.8929 gram per cc. Okay. And then spring constant. And spring constant that designated at K is equal to 2.3 kg centimeter. So, we have to take the reading. Let us say that initial angle let us say this is position 1, position 2, position 3 and position 4. This position 1, this position 2, this position 3 and this position 4. So, you have to see what will be the initial angle. Let us say that initial angle in position 1 is 43 degree and position 2 let us say 22 degree and initial angle in position 3 let us say 44 degree and for the position 4 this angle is 39 degree. Now, what is final final angle. That means when you are rotating, then this is the initial angle for position 1, 2, 3, 4, and similarly for the final angle. Let us say for the position 1 is 65 degree, for position 2 is 44 degree, and for position 3 is 77 degree, and position 4 is equal to 64 degree. So, you can make the table in this form. So, what will be the angle of twist? Angle of twist will be, you can see 65 minus 43, 22, 44 minus 22, 22. So, angle of twist will be equal to will be equal to 22 degree. Okay. So, you know the angle of twist is equal to 22 degree. Now, you know the equation. You know the equation for torque. Torque is equal to theta of final minus theta of initial, this into k into pi, and this divided by 180. So, what is theta in the final? That is 65, and theta initial is 43 degree. So, you can write that 65 minus 43, this divided by 180, this into k into pi. Again, if you deduct, then it will be the 22 divided by 180, this into k value. So, k value also is given, that is spring constant. This is spring constant is k 2.3 kg centimeter. So, this into 2.3, k value is 2.3. So, this into this is pi. So, if you calculate, you can have the 0.883 kg centimeter. So, you can calculate that what will be the torque. So, torque value is equal to 0.883 kg centimeter. Now, we have to determine what will be the shear strength of the soil. So, you know the earlier this equation for the shear strength of the soil. Okay. In vane shear test, so shear strength that is Cu. So, Cu can be expressed as T this divided by pi into d square h this divided by 2 plus d of q divided by here T is equal to, as you know, this is 0.883 kg centimeter, and h is equal to 2.4 centimeter, and d is equal to 1.2 centimeter. So, Cu can be written as T 0.883 this divided by pi into d square is 1.2. So, 1.2 square into h is equal to 2.4. So, 2.4 this divided by 2 plus dq, d is 1.2 q, 1.2, this is q, this divided by 6. So, if you calculate, we can have 0.883, this divided by 6.333. So, this will be equal to 0.139 kg per centimeter square. That means, this will be approximately 13.9 kPa. So, shear strength Cu is 13.9 kPa. Bend shear test is very important, and now you know how to evaluate the shear strength of the soil by the bend shear test. You know what are the theory, how to calculate the torque, and you know what is spring constant, you know what is the diameter of the vein and the height of the vein. So, you can also determine torque at a rotating at a particular rotation, in the initial rotation and the final rotation. You take the difference of the theta final and the theta initial and the spring constant. So, you can calculate the what is torque. If the torque is known and you know the diameter and the height of the vein, so you can calculate the what should be the shear strength of the soil, saturated soil, using the bend shear test.